Chapter 2 of tm55203 Maintenance of Operation of Diesel Electric Locomotive. 4. General description. The diesel engine is an internal combustion fuel oil burning engine employing the compression ignition from the engineering, frequently referred to as the prime mover. It converts that heat energy into the mechanical energy. An internal combustion engine is one of the derived from the power from the burning of the charge of the fuel, which is confined in a space called the cylinder. And external combustion is operated by the expansion of the gauges, which have received engineering from the fuel burned in separate chambers. As is the steam engine, the compression ignition occurs when the fuel is ignited solely in the heat of the compression. By the heat of the compression, this is caused by the fuel coming into the contact highly compressed and hence in the highly heated air cylinders. The advantages of a various type of the prime movers, even the various type of the diesel engine vary their application, but the diesel as a group has a certain advantage which should be known by these working with them. The fuel economy is the principal advantage of the diesel. Fuel economy is the principal advantage of the diesel electric motor. This is due to the high compression ratio, the proportional high expansion ratio, the thermal efficiency then found in other internal combustion engines, the high percentage of the British thermal units (BTUs) that are covered to the useful work also exceeds the use of the steam engine. The torque of the diesel engine is fairly constant throughout the speed of the range, and therefore the engine pulls well as low speeds. 3. The fire risk is low because the fuel is not volatile as gasoline. The exhaust gas is not dangerous as that of gasoline engine, although the poor combustion causes the high concentration of carbon monoxide fumes. 5. The compression ignition eliminates the need for the ignition system. 6. The engine is highly reliable under the variety of weather conditions. The classification. Diesel engine are classified by the following principles operating the characteristics. A. The operating cycle. 2-stroke cycle or 4-stroke cycle, paragraph 10. B. The cylinder arrangement, chiefly in the inline or the V-type. C. The piston action, single action or opposed position. D. The speeds of trending in the medium of the high-speed engine, particularly on the locomotives. DE, the method of fuel injection, predominantly mechanical injection type used in locomotives. Diesel electric locomotives are classified according to the type of the service that they are designed to perform. Switchers, road switchers, which causes freight passengers and yard services passengers. None of these are military fleet. 5. The principal operation, the heat injury and the mechanical injury, the transformation of the heating energy to the mechanical energy by the energy is based on the fundamental law of physics, which states that the gas will expand upon application of heat. When the gas is confined with no outlet of the expansion, the pressure of the gas increases the heat. The pressure acts as against the heat of the piston, causing the piston to move away from the combustion chamber. B. The reciprocating motion of a rotary motion. The downward movement of the piston transformed into rotary motion through the connection of a rod and the crankshaft. The cylinder is hollow and tube closed at the upper and end of the cylinder head. The piston moves inside the cylinder. The connection rod is straight. It is upper and end is attached to the bottom of the piston. When the motion is reciprocating up and down, whether the motion of the drive shaft is rotary, the necessary the transformation is accomplished by the crankshaft, which is motion in the bearings and both ends and that can revolve freely. One of the crankshafts that are offset of the parts are known as the crank or the throat, of which the lower end of the connection rod is fastened. The piston is forced down by the expanded gas connection rod, moved down, and also it must be followed the circular path described by the throw of a crankshaft. Thus, the reciprocating of the motion of the piston is transformed into the rotation movement of the crankshaft. Factors necessary for the proper function of the diesel engine. 4 factors are necessary for the proper combustion in the diesel engine: air, fuel, compression, and ignition. Any discussion of the engines must be based on these factors and the methods of delivering the fuel and timing of the combustion chamber. The principal difference between the diesel engine and the gasoline engine is the method of emitting ignition fuel or igniting the fuel. Pure air is compressed at a high temperature before it is delivered to the diesel engine, which differs the air-fuel mixture delivered by carburetors and gasoline engines. Fuel oil is injected with the cylinder of the diesel and finally divided into ignited hot air. The fuel is consumed by burning rather than explosion, injection, or burning, continuing the applicable portion of the stroke stroke. The relatively constant pressure is thereby maintained during the entire power stroke. The characteristic of the diesel engine classification is the constant pressure engine. 6. Combustion principles. In the first diesel engine, fuel oil was injected by the cylinder by the pressure of the pump. The result was poor. Poor since the pump was not delivering the oil high enough at the pressure to atomize the oil that entered in the cylinder through the spray nozzle. Since the pressure of the pump and the justification of the air blast introduced with the sprayed oil somewhat of the fashion of the performing the atomizer. This air at 900 pounds of pressure was supplied at 2 to 3 stages of compressors. The air injected in the diesel had been superseded by the mechanical injection of the solid injection diesel. The change has been due to the high cost of the compressor. About 20% of the entire engine caused operating difficulties with the compressor. The better the efficiency sound injection engine and the ability of solid injection diesels to operate satisfactorily depends upon the delivery of finely atomized charged fuels without leakage after dribble and distribution with principles that particles of the fuel into contact with sufficient oxygen to complete the combustion without reasonable degree of combustion efficiency. The power developed for each gallon of fuel would be low, thereby eliminating the economic advantage to propose through theoretical diesel engine cycle. The entire charge of the fuel injected into the engine cylinder is not completely burned, and the unburned will settle on the cylinder wall and piston level, leaving a sticky mass of the carbon. The carbon will be filled with between the piston ring and its groove, finally binding the ring so that the ring is no longer seals with the piston against the blow-by. Other portions of the carbon settle in the exhaust valve as it causes the valve to leak. This reduces compression to the point where the air temperature does not reach a high energy value during compression of the ignition of the next fuel charge. 7. Atomization. Oxygen charge in chamber contacts with the carbon and hydrogen atoms that are surface of the fuel, the oil particle. The oxygen cannot penetrate into the interior of the fuel oil drop. To obtain the largest surface of the oil must be divided into the greatest possible number of the fine particles to ensure the spray, which is equal to better than the atomization obtained by the perfume atomizers. The entry spray level must be properly designed. There must be a proper correlation between the fuel oil pressure, the diameter of the orifice, and even the fuel particles in the proper broken up to the most complete diffuse through the oil air charge. They may be accomplished either by the nozzle or spreads of the fuel in the wide cone spray patterns of some arrangement where the air is diffused from the fuel charge and the diffusion of the fuel charge. Usual spray is supplied with several openings in the tip. The fuel tips through the holes of the form. The equal number of the cones are atomized by the number of the efficiency fit in the combustion space. Combustion space. I lost my spot. We'll just say, even in the fine particles broken down, they must be completely diffused in the air charge. This may be accomplished by the nozzle spray and by the fuel as wide as the spray pattern in some arrangement where they diffuse through the fuel of the oil charge. This diffusion of the fuel charge usually spray is supplied with the several openings in the tip. The fuel issues the holes forms equal numbers of the cones atomized by the fuel efficiently with the combustion space in the engine cylinder. When with a medium large bore engine cylinder, the multiple orifice gives an ideal spray information. The size of the engine cylinder decreases. The high-speed engines are as a class or small bore. The amount of the fuel injected into the engine cylinder is very small. The diameter of each of the spray valve openings must be exceedingly small. After the spray enters into the diffused cylinder, under the three-stage combustion process follows. The fuel particles must be heated in a temperature high enough to permit the self-ignition upon the meeting of the oxygen. The heating of the necessary even if the fuel remains in the liquid state. Since the fuel actually vaporizes before the ignition, it must be heated with the firing of the temperature of the range of about 70 to 900 Fahrenheit. Vaporization starts at the head of the first droplet, enters in the cylinder, continues until the combustion occurs. The second step of the combustion process is ignition of the fuel charge. Ignition occurs shortly after the first fuel particles enters into the cylinder. The time or interval Is this ignition lag of the various kinds of fuel, the compression pressures other than engine characteristics, ignition may start in any portion of the fuel spray. The first flame may occur to the point removed from the spray nozzle, may occur simultaneously with several places. Well-designed engine ignition occurs before the entire fuel charge enters the cylinder and burns. The third step is the combustion process, follows the fuel burning as fast as it enters into the cylinder. D. The combustion knock. The initial ignition is delayed and so long that the entire mass of the fuel is entered in the cylinder has become the vapor. The primary ignition may be followed by the rapid combustion of an explosion of the entire fuel mass. The explosion may set up the pressure wave which, traveling at the speed of sound, strikes to the metal of the walls, thereby producing a sharp knock called the combustion knock. It is then highly described to arrange the design so the first part of the fuel charge is ignited before the entering the air fuel charge enters into the cylinders. The flame of the first particles to ensure the continuous ignition and the combustion reminder of the fuel. The faster the fuel enters in the cylinder, to accomplish this, there are various designs of combustion chambers, all intended to prevent the combustion knock. He must design all the fail in the purpose of combustion to take place after the injection has stopped and turned with the afterburn burning. The rate of the burning during the period is a slow result and little of the power increase during the afterburning period. The combustion chamber contains a mixture of nitrogen, oxygen, carbon dioxide, steam, vaporized fuel products of the particular combustion. Inert gases and high of combustion have been completed as a result of mixing actives. Gas subsequent combustions takes place slowly, extending to the late is 80 degrees of the crank travel after the top of the center. The late burning of the low expansion rate decreases the overall cycle efficiency of the engine. Although the final combustion efficiencies may be high, difficulty obtaining the mixture of the fuel of the air, securing the efficiency of the combustion, increasing the engine speed, and increase of a 4-cycle diesel at 300 revolutions per minute injects of the burn of the fuel charges in 30 degrees of the crank of the travel, such as engine covers of 1800 degrees of the crank travel per second as into 30 degrees of the injection. Combustion occurs approximately 0.017 thousandths of a second. The high-speed diesel engine turning at 1800 RPMs will use this 30 degree of the crank travel. The actual time of the interval is about 3/10 thousandths of a second. Method of mixing air with fuel. Generally, the method of moving the air with the diesel engine cylinder with the flow across the fuel stream varies, and the different engine method are common with the engine found in the locomotive of the military fleet as described below. B. The entrance swirl. The air flowing into the engine cylinder may follow a circular path while motioning with a continuing during the compression spoke of the fuel is sprayed with the cylinder of the air through the fuel spray. This increases through the mixture of the air and the fuel. Piston swirl. The position has the concave thrown crown. The air between the cylinder head and the outer surface of the piston cut around is forced into the concave section of the piston approaches the piston swirl. The piston has a concave crown of the air between the cylinder head and the higher outer surfaces of the piston crown, forcing the concave with the piston approaches the end of the stroke, and the air mixes with the fuel spray and toward the center of the piston. The turbulence chamber in some diesel engines, the Caterpillar, for example, the fuel spray is injected with the turbulence chamber and meets the entire mass of the air which has been velocity with the piston motion rotates the turbulence chamber, and at the high speed the turbulence chamber is either the cylinder head or the upper portion of the cylinder, casting the position of the small valve of the combustion chamber to the greatest importance. The fuel spray is not directed toward the throat of the connecting the chamber with the cylinder. Combustion will not complete. The engine will not put its rate loaded, and the fuel spray must be across the airstream. There is an operating difficulty, however. If the engine has been stopped for some time, the turbulence chamber becomes cold. The air warmed in the cylinder, the compression rushes into the turbulence chamber and loses the heat and cooling action of the cool metal of the throat. It's necessary for the provided some detail of the added heat to the air. The device may be coil heated in the electricity from the starting battery. Pre-combustion chamber. Pre-combustion chamber, the feature of the several high-speed diesel. When the low position completes the compression stroke of about 35% of the air charges is forced into the pre-combustion chamber. The air is forced into the chamber and is not enough to ignite is not enough to unite the complete with the fuel charge. When the fuel sprays in the chamber as a result, the carbon monoxide is formed, and some of the fuel vapors pressurize into the particle combustion and cause carbon monoxide gas and vaporized fuel to blow into the engine cylinder, where the gases mass mixes with the hot air combustion is completed. One advantage of the pre-combustion system is that the fuel may be injected early enough to heat up the vaporized without the danger of serious pre-ignition, and limited amount of the pre-combustion chamber holds the pressurized at reasonable low value. Disadvantage of the pre-combustion chamber is difficult starting because of the relatively slowness of the engine warm-up. 10 operating cycles. Generally, to produce power through the interval time, an engine must accomplish a definite engine series of operation, performing them over and over and again. The series is known as a cycle, in which the situation, compression, ignition, expansion, exhaust takes place in the order listed. The engine requires the 4 strokes and of the piston, true revolution, and then crankshaft to complete the cycle is known as the 4-cycle engine. Figure 1-1, while the engine completing with the cycle of the 2-stroke of the piston, 1 revolution, the crankshaft is known as the 2-stroke engine. Figure 1, the diesel engine is used in the per locomotive of the military fleet operation. Military American Locomotive Company, ALCO. Caterpillar Cumming manufactures 4-cycle engine manufactured by the Electrical Motive Division of the General Motor Corporation, EMD, or 2-cycle engines. The 4-stroke cycle of the suction stroke. The suction stroke begins with the piston, the top end and center of the piston moves downward, and the charge of the fresh air is drawn in the cylinder through the inlet valve, which holds open the cam. The air passage is closed, and the piston reaches the bottom of the stroke. The crankshaft has then been made a half revolution during the stroke. The 4-stroke of the cycle compression, the piston reaches the bottom of the stroke, and the inlet valve is closed, and the spring of the high point of the cam rotates under the push rod. The bottom dead center has been passed, the piston being forced upward toward the cylinder head. Inlet and exhaust valves are closed, and the upward travel the piston compresses the air cylinder with the end of the compression stroke, and the reach charge of the oil injected through the spray valve in the cylinder. The ignites is spontaneous as soon as it mixes with the air in the cylinder. The piston compressed with the air and about 500 pounds per square inch. High compression of the rates of the rates of the temperature of the air to the flow about 900 degrees Fahrenheit, which is high enough to ignite the oil without a spark. The crankshaft has made another half turn during the stroke. The 4-stroke cycle expansion strokes as soon as the crank moves and past top dead center. The piston pressure created by the burning of the fuel, the force in the piston downward to cause the crank to rotate, delivering the power of the crankshaft. The oil contains the spray into the cylinder with the piston moves in the distance. With the expansion of the stroke, the gas continues to exert the force of the piston until it reaches the bottom dead center. At this time, the exhaust cam opens the exhaust valve, and the crankshaft has made another half turn during this stroke. The 4-stroke cycle exhaust stroke. As soon as the exhaust valve is open, most of the burned gas rushes out of the cylinder. The exhaust valve continues to open the position during the next upward stroke of the piston. When permits to complete the removal of the exhaust gases, the crankshaft has made another half turn, completing the 2 full revolutions during the first 4 steps of the completing cycle, which is repeated again as long as the engine is running. The 2-stroke cycle compression, the stroke of the vent of the compression, injection, and expansion of the 2 placed in the same in the order of the 4-stroke cycle. The upstroke of the piston, the compressor of the air, and the air, the injection of the fuel occurs within the piston near the top of the stroke of the eye. The glass expand against the piston, forcing the downward up power stroke. To the 2-strike cycle of the power stroke, the piston near to the bottom of the power of the expansion stroke. The exhaust of the valve in the top of the cylinder opens the hot burned gases, then rushes past the valve. The piston moves farther down, and the air intake the port into the cylinder wall near the lower, and the air uncovered intake exhaust takes place at the same time. The fresh air enters the lower in the cylinder, forcing the remaining of the burned gas out of the exhaust valves at the top of the cylinder, filling it with fresh air. The exhaust valves close, and the engine is ready to start another cycle. The intake fresh air and exhaust of the burned gases takes place at the same time. This is a 4-stroke. It shows the exhaust coming in with the intake valve and the intake stroke, and the compression stroke is compressing and at the top of the and then rotate into the injector, followed by an exhaust stroke outward. This is a 2-stroke cycle. The exhaust and the valve, the exhaust and the intake take out, leave it at both sides. The spray comes in with the compression these injector sprays, the compression, the expansion stroke is ignited, and it's a two-stroke. Fuel injection. Fuel automation penetration. Fuel is enforced by the combustion area of the extremely high pressure of 1200 psi, a high of 3500, depending upon the design of the engine, the per psi, which required for the assured opera's itemization, mixing the fuel air and the combustion area. The recommended the compression pressure, the approximately 500 psi. Therefore, the injection pressure, the considerably higher. The higher pressure, the better atomization, mixing the air and the fuel. Turbulence, paragraph 9a and b, will assure that even the burning of the fuel give the desired downward pressure on the function of the injection system. The function of the injection system is the meter of the fuel accurately delivers equal amounts to all the cylinders as the pressure high enough to ensure the atomization controls the start rate and duration of the injection. The injectors are connected with the engine governor that assures the maintaining of the power requirements, increasing the degrees with an increase or decrease in load. Part 2, Diesel Engine, Chapter 3, Railway Diesel Engine.